Welcome back. Today we're doing number 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. So example 1 is this input S equals BABAD, and the output is BAB, and ABA is also an answer here. Example 2, S is CBBD, and BB is the answer here. Okay, so when I'm looking at this, I think the first thing I'm thinking about is whether or not I have to visit every substring. And my instincts tell me yes, because how else would I know if something is a palindrome? Now, what makes something a palindrome? Well, it means that starting at some point, I guess here, if I flip this, it's the same string, I guess backwards and forward, right? So if I flipped, if you imagine flipping this whole word, B is here, A is here, B is here, A is here, and D is here, we can check if this is a palindrome or not, right? So in Python, you can do a reverse string and you could do a reverse string match, right? So is the string equal to the reverse version of this string? Now, it's not the most efficient way to get a palindrome to do this O of n operation of reversing and then the comparison. The comparison is probably another O of n operation, but visually and code-wise, it's actually a very easy way to think about it. This is just a reverse of the other string, right? If you want to super optimize, I guess you could optimize a little bit more. You could choose the bounds of the strings that you're thinking about, so here and here, and you can check whether these are equal. If they are, you move it closer. Whether these are equal, and whether they are, you move it closer. And if these are equal, right? You can actually do it the other way around too. You can start in the middle. You can see if these are equal. You can move it outwards. See if these are equal. So ABA, right? So the A and the A is equal, right? So I guess what's a good way to visualize this? So the B was equal. The A's are equal. Awesome. We move it out, and the B and the D are not equal. Let's make that red. Those are not equal. So starting from some point, this point, the longest palindrome starting from this point, if these were the beginning left and right, are of length 3, and starting index was here, right? That's index equals 1. Knowing a starting index and the length of the string, it's actually easy to get the string, right? You can get the string by starting index, and then that's starting plus length, and that's going to give you ABA. And that's one of the insights we're going to use, in that in this comparison function, we can start from the middle, we can start from the ends. I think for this problem, we'll start in the middle, and we can write a function that gives us both the starting index and the length of the longest palindrome starting from that position. Now, let's think about this actual problem, right? It's B, I believe it's this one. So what does it mean to have a substring? Well, we're going to be able to check this string right here, the string B. We have to check BA, check BAB, check BABA. We also got to check D, right? And really, from every position, we're doing a similar check. So we're going to do this check here. Let's shave off the ends here. We're going to do the check here. And we're going to do the check here. And we're going to do the check here, right? Obviously, shaving off the ends here because we're not going to check off string, right? So we have to check all of these substrings, right? So here, this will be the B, this will be the BA, this will be the BAB, and so on, right? You can imagine these are the substrings that we have to check, where for any given one, like let's take this one, for example, right? This one, this green one right here, is going to become this substring, right? We're going to check all these substrings. Now, what's an efficient way to do that? Well, we can, iterate through the string and consider those substrings, right? So we can iterate, have a pointer I here and move that I all the way down, right? And if we think about the function that we talked about before, a function that could take some midpoint, some, L and R, we can call that function and get the longest substring on here, right? So there's one thing to consider that is very important here. A string can have an even number of letters or an odd number of letters, and that changes how we do a palindrome, right? So imagine we're iterating through the string and we get to, let's say, this A, right? Now, is this A the middle? Is it, let's see, this is gold. Is it this middle right here, right? Or is it actually this, right? Is it, at what point should we attribute this I to the odd version of the string or the even version of the string, right? So on our iteration, we're just going to do both, right? So we're going to check different cases, right? In the first case, for I in range length of the string, we're going to check this I being the exact middle, right? So we're going to put the left pointer, and that's going to be equal to I, and we're going to have a right pointer, and that's going to be equal to I. And that's going to act like it's the exact middle, right? So it's going to be here. And then what if it's even? Well, it's even. We want it to be BA, BAD, where A, right, it's actually the last index of the left pointer, or the last index of the string here, and our right pointer is going to be right here, right? So instead of starting, let's see if I can do this quickly enough so you don't get bored. Instead of starting our left and right pointer here, we're going to start our left and right pointer here, and then we're going to do what we did, what we talked about before, where we're going to move outwards and check if the string is a palindrome, or maybe what is the longest palindrome I could start from that position, right? Here we can actually see that A and B are not equal. So the longest palindrome that we could start at this position will be 0. No palindrome is available in this position, right? Go ahead and give it color if you want to see it. Here, right? A is equal to A because, that's just what A is. And then we move left and right. We'll move left here. We'll move right here. Is B equal to B? B is equal to B. So the longest will actually be of length 3, and the starting index will be this 0 right here, right? If these were the indices. Use gray. Okay, so there's a couple functions that we'd want, or at least there's one function that we want, is how do we get the longest pal from a left and a right pointer, right? And this is going to return some integer which represents the longest palindrome, and I guess it should also return an integer that is the start index, right? So I'm going to put length here and then index, right? Starting index. Start, right? Now we need to do a just move this here. Move this to the side. So case 1 is left equals I, R equals I, and then we're going to, get longest palindrome. So this length, this start equals this function, right? And then save if you know, longest scene, something like that, right? And in the second case, L is going to be I, and R is going to be I plus 1, right? And then same thing. We're going to call that function the helper function, and we're going to save if it's the longest one we've seen, right? So that's going to be this one right here, and this one is going to be this one, right? Okay, so that's basically the code. There's going to be some juggling with indices, so that's probably going to be the most confusing part. But with this code in mind, let's start mapping it out, right? Move this to the side a little bit and make this a little smaller. Okay, so what's necessary here? We probably want some type of max length scene, right? Or max, whatever, like max length that's possible. And I guess we can start it as 1, because every individual letter is a palindrome of its own letter. And then we'll have the max length start position, and the start position will be 1, right? So even if nothing happens, right, then if we want to return some type of string, it would be S, and that's going to be the max length. I'm going to delete length here and just make it len to keep it short. The max length start to the max length start plus max length scene, right? So we're going to have some logic here that updates these two variables, right? And if these two variables are never updated, well, you know, what is the max length scene? The max length palindrome is always going to be at least the first letter, right? A single letter, the first letter, right? So here BABAD is the input, and the output that I put with no logic at all is at least we can have the first letter as a palindrome, right? Just the letter B, here just a letter C, here just a letter A, right? Okay, so let's do some logic to try to update that, right? We don't want this as the actual end-all be-all, so let's iterate over the list, or the string, and let's do some logic with it, right? We can do case 1, which is I position is mid, right, in an odd length palindrome, right? And then case 2 is I position is the starting left position, and then right equals I plus 1, right? And this is the even length palindrome situation. So these are the two situations in the string where I'm just going to move this to the side here. I think we know the problem. These are the two positions that matter most, right? And we need some type of helper function that's going to help us get kind of like a longest from this left and right, where it takes a left and a right, and it's able to give us that longest from this position, right? So the longest from this position, we can build this first, because it's kind of a standalone. It's kind of a standalone function, right? So you can imagine if I called this function on the input of BABAD, and let's say I want left and right to be here, right? So this is index equals 1. Well then, L would equal 1, R would equal 1, and I want this function to return 2 ints, but the 2 ints are it returns a length of the longest pal length, right? Or you can just say max palindrome length, longest from left and right, returns some maximum at the starting index. Okay, so what do we have to do? We have to iterate while these things are true, right? So while SNL is true, then we're going to decrease L and increase R, and what is the length? So we want to save the length. We'll save the length before, right? So before this happens, make that 0, and then max pow length is R minus L. I think you have to do a +1 here, right? Because let's say you're here, and L is 0 and R is 2, then 2 minus 0 would be 2, but that's not the length. The length would be here at 3, so you have to do the +1 to offset it, right? And then you can return max pow length at the end of this, and the starting index. What would the starting index be? Well, we're not saving it anywhere, so that's a problem. Starting index equals 0, or I guess it could equal. I guess it could equal left. Then this should be 1. I don't think it matters because this would be overwritten, but if you think about it, the max pow length is not, it doesn't start as 1 because it's 0, because what if it's not the same index, right? So what if it's B and B? And the starting index, I guess this doesn't matter as long as that's 0, right? So max pow, and then the starting index is L. Now when does this break? What if it's not even, or what if it's out of bounds? I guess we have to check out of bounds as well. So while L is larger than or equal to 0, and R is smaller than the length of S, and these are equal, then we continue, right? So what we don't want is, let's say we have an L here, we don't want the L to, oops, what just happened? We don't want it to go from, let's say this A is where the L is. We don't want it to go to B and then go out of bounds, right, to -1. At the same time, we don't want the R to go from here to here out of bounds, right? So we want it to be smaller than the length of S. And we want those to be equal, and then make sure that we return starting index. So depends on how much time you have in an interview, but you can imagine I can run this on, let's say, longest from L R, and let's just choose an arbitrary one. Let's choose L as 1 and R as 1. And let's print this. Invalid syntax. Right, so let's fix this line. So this and this here. Okay, so we standard out 1 to 1. So the max length here is 1. Starting index is 1. Is that true? I don't think so. If it's 1 here, I wonder if this is even the right one. So yeah, so this is a tuple. And we would expect max pow index to be 3 because it should be BAB. So let's see, as long as this is greater than 0 and R is smaller than length and these are equal, then the max pow length is this, right? And it's always updated. Starting length is this. Oh, look at this typo. This is a crazy typo, right? What is this even? Minus plus L. Minus plus L. Does that even do anything? It should be minus plus minus equal 1. This should be plus equal 1. Huge bug. Huge bug. Huge bug. So this should return 0. The starting index is So this should return 3. The length is 3. Starting index is 0, right? So starting at that point, I'd expect this, right? Starting at something like, let's say we start at 2, right? 2, 2. So here, right, 0, 1, 2, we'd expect this to be the longest palindrome, ABA, so that should be 3 and 1, right? So 3 and 1, perfect. So this gives us the length given the left and right. Let's get rid of that. And let's do these two cases, right? So in the first case, I is mid, right? Let's just remind ourselves what we're doing. Let me bring up the diagram right here. So in the first case, right, as we're iterating over I, we have a left and a right pointer. And the left and the right pointer start exactly where I is, right? So here, that's I, this is I, this is I, this is I, this is I. We're going to do left and right pointer. What is the largest palindrome starting from this position, right? And, you know, so you'd expect this I to iterate 5 times, and left and right would be these 5 positions, right? And what it's going to do is it's going to use the O of n operation to do the expansion. So starting here, what is mid? Mid is going to be going this way, right? Where left continues left, right continues right, and then it does that check. Okay, so that's this one. So here, I is equal to, L is equal to R, which is equal to I, right? This is our mid. And we're going to get, we're going to call longest from L, R, and we're going to pass in that L and R that we have, right? And what does this return to us? This returns to us a max palindrome length, right? It returns to us starting index, and that's going to be in the tuple that we can use. And as long as this is longer than max length seen, we can set it, right? So if this max pal length is longer than max length seen, we reset it, right? So that means that max length seen is going to equal this right here, this pal max palindrome length, right? And then we update the start, right? The max length start equals this starting index, and that's this right here, right? And yeah, that should be that. I wish I chose shorter variable names because these are super long. I'm just going to rewrite it a little bit. Start index. Okay, that's a little bit shorter. And then here we're actually doing the same thing. We're just using a different L, which is starting at I, and then an R, which is starting at I plus 1, right? Let's put these in different lines so it's a little clearer. And then we're actually doing the same operation, right? We're doing longest from here. We're doing that check, and then if that check exists, we're going to update it. All right, so let's just review the code. Max length seen starting at 0. Max length start. Max length seen starts at 1. Max length start starts at 0, right? So even before we had any of this, right? This right here, before we had this at least returned to us the first element, and first element is a palindrome, but it's not the longest palindrome. So we're going to do some logic to figure out what the longest palindrome is, right? We're going to iterate I towards everything, and there's going to be 2 cases. In one case, I is going to be here, L and R, and in the second case, I is going to be here, and R is going to be I plus 1, right? And then this is going to iterate downwards. Now, looking at it now, I realize I don't have to iterate over everything. I just need to iterate over this to the position that's 1 away, right? And hopefully you can see why. Because one away is fine. I don't actually have to get to this last point, because the last point is going to be, at best, a palindrome that's going to be of length 1, and that's going to be the letter D here, right? So here, I can actually just go to length of S minus 1, right? And let's try it and see if there's any issues. Okay, great. Awesome. So runtime 331 milliseconds, memory is this much. Let's think through the runtime and see what we have here. So what's the runtime of this? This is an O of n operation, because at any point we're going to expand outwards. That's O of n, right? This is an O of n operation. We're going to iterate I over, but we're going to do 2 of these points, so, right? So it's like O of n, it's like O of n times 2, or 2n, or 2 times O of n, right? It's going to be 2 O of n's here in this O of n, so this is going to be n squared. And this operation here is, I guess, another O of n operation. So totally, the worst time complexity here should probably be n squared, right? So we're going to iterate through all of these, and for every one of these we're going to do a comparison that costs us O of n. Awesome. So hope that was helpful. Thanks for sticking through this drawing process. Hopefully some of this makes sense. There is an idea that hopefully makes sense of using that I, right? Using that I and iterating over it. I will see you guys on the next one. I'm going to write the title here, and I'm just going to reuse. What should I reuse? Let's let the audience decide. I'm going to reuse this, I guess, as the substring idea. Probably don't need that. Something like this. Yeah? Alright, thanks a lot for watching, and I will see you at the next one.